Let's talk about ham radio. It's been a while. In fact, specifically, let's talk about QRP, and more specifically, portable QRP. What most people think of, now QRP, in case you didn't know, means a low-powered radio, usually 5 watts output or less. It generally also means small and portable. And what most people think of when they think of a QRP radio is something like this Yaesu FT817. Now, it's a good little radio, but it's an appliance. And it's power hungry. It's only 5 watts output, and it does a lot of stuff. You know, it does all the HF bands. It does 60 meters. It does 6 meters, 2 meters, and 70 centimeters, also known as 430 or 440. And it does all of those with all modes. It basically does everything from 160 meters through 70 centimeters with the exception of 220. And 5 watts output, all modes. AM, FM, single side band, digital, CW, the works. But the problem is it's a little bit fragile and it uses a lot of power. Now, it's got a battery compartment, so you can put a battery pack in it. I think they actually come with the battery pack now. Back when I bought this one, they were the battery pack, if I remember correctly, was optional, but I did buy a battery pack, and I wore that battery pack out and then never bothered to replace it, because there have been 2 battery packs available for it, one of which was 1 amp hour or 1000 milliamp hours, and the other one was 1.4 amp hour, 1400 milliamp hours. And even the 1400 milliamp hour battery under normal conditions would only go about maybe 3 hours tops on a charge. So I've pretty much used this. Now, I've used it mobile a fair amount, and you know, you can rig up a power cord to be able to plug it into your cigarette lighter outlet in your vehicle, and it'll run well off that, which a 100 watt HF rig won't. And you would really, if you haven't tried it, you will be amazed at how well 5 watts works. You'd be amazed at how well 1 watt works. I've talked to people single sideband with this at the 1 watt setting into a mag mounted hamstick antenna on 40 meters, which a hamstick is a low profile mobile antenna. And I've talked to people 1,000 miles away with 1 watt on 40 meters using that. But like I said, it's not a trail friendly radio, which by the way is an idea that somebody came up with in the ham radio club called Adventure Radio Society, which used to exist back in the 1990s, mid-90s, and it was all about taking QRP radios on the trail with you and operating out in, you know, in the field with low power and so on. And the thing about a trail friendly radio is that you had to be able to take your power source, your antenna, and everything while backpacking. And with something like this, sure, you can take the radio backpacking, you can take an antenna backpacking, but if you're going to be out there very long, you're not going to do well with it, because like I said, it'll run about 3 hours on the internal battery. About double that on something like this, and this is getting very much too heavy for backpacking. Although, you know, if you got a solar panel like this, you could perhaps keep it charged, Or you could even you know, run on the internal battery and use this to recharge the internal battery, but you're not going to do a whole lot of operating. So specifically, this draws about 450 milliamps on receive, and that's a lot of current, man, for what's supposed to be a little portable radio. So I use this, you know, I use it when I'm camping out of a vehicle or whatever, you know, motel room or what have you, where I've got a ready source of power. I usually actually carry a plug-in power supply to use with this. One of the better choices, and the real subject of this video today, is the 4040. This was designed by Dave Benson, NN1G, who has since changed his call sign to K1 SWL, I think, for Small Wonder Labs. And so he came up with this design. It's a little superhet, crystal filtered, VFO controlled QRP transceiver with full break-in, CW only, and it's a single band. And it does about maximum about 1 watt. And but I keep mine down to about between 100 milliwatts and 500 milliwatts, or half a watt, at which point it still, you know, I mean, it works well for making contacts, and it's very battery friendly because it's less than 100 milliamps on transmit. So that's less than a quarter of what the FT817 draws on receive on transmit. On receive, it draws about 20 milliamps. And so, you know, on a little battery pack of, say, what I used to have in it, I built a nickel metal hydride battery pack into it, 7.2 volts, and about, I think it was about 2,400 milliamp hours at the time, but you can get 3,000 milliamp hour AA nickel metal hydride batteries now, so that's the same size. So with a setup like that, man, you can go many hours of operation. Well, let's see, 2,400. If you're actually operating at 20 milliamps receive and maybe 100 or a little less than 100 milliamps on transmit, you're going to average maybe 25 milliamps. So 25, that's 4 hours for 100 milliamps. So 40 hours for 1,000 milliamps. So that's 120 hours of operating on the internal batteries I used to have in this. I don't have it in it anymore. But and another way you could go now is some of the 18650, a pair of 18650 lithium cells, which are also about 3,000 milliamp hours. So again, over 100 hours of operating with this. Double that with a battery like this, but that's really a little bit too heavy, you know, for backpacking. Oh, I was going to show you this. If you're going to do very much operating with the FT817, you would need a battery like this, and you are not going to backpack with a battery like that. That's 20 amp hours, 20,000 milliamp hours, but it's just too heavy. So hence we have something like this. Now, what is in this is this single board transceiver. This is one for 80 meters. I have another one around here somewhere for 30 meters, and it was the first one I built. This one is 40 meters, and this is the one I've used the most. I've made a lot of contacts on this. And I don't remember exactly what I had the power set at, but somewhere between 100 milliwatts and 500 milliwatts, or half a watt. And like I said, I made a lot of contacts, and I modified it a little. Of course, I picked up this enclosure in a junkyard and built the board into it. I'll just talk about that a little bit. Now this actually was and is a trail-friendly radio. It's a little bit bulky, but it's pretty much self-contained. And so what I did was, it's got varactor controlled VFO tuning, which is voltage controlled diode. So I've just got a 10-turn pot in there with a reduction drive, and that's how it's in this position, and that's how you change the frequency. But what I also had, I added this. I put this little toggle switch here, and what that does is that switches in instead of the main tuning pot, it switches it out and switches in a small screwdriver adjusted pot. So what I could do, and did do in fact, was adjust that to be exactly on the QRP calling frequency. So in this position we're on 7040, which at the time was the QRP calling frequency. I think it's 7030 now. Back then it was 7030 in Europe and 7040 in the US, and I think it's 7030 everywhere now. But so I could put it in that position, and I was directly on, just like I was crystal controlled or something, on the calling frequency, or put it in that position and use this. And what else did I have? Spot. Okay. This little momentary push button controls a frequency annunciator. So what it would do is, when you press that button, it would read out in Morse code, in the side tone, it would tell you the frequency it was on. So you could search up and down until you found some activity, and when you found activity, push that and it would tell you what frequency. So the other thing that I put in it is a keyer chip, a TIC, which is a tiny CMOS keyer, and it just comes on a little tiny board, and it has, I added these micro switches to act as an iambic paddle, and this single micro switch is not connected to the keyer, it's just connected to the key line, so that's just a straight key. And the TIC keyer uses so little current that 3 AAA cells die of old age before they lose their charge. So once they finally die of old age after 10 or 15 years or whatever, then you take them out and replace them. And what I did, since they last so long, since this draws so little current, it draws like a micro amp or something, and so I didn't even put a power switch in the keyer, and the keyer, you know, had its own batteries, and you didn't have to turn it off. It went to sleep after a certain amount of time of not being used, and as soon as you touched one of these or this, it would come back to life. So there was no point in having an on-off switch or anything like that, and I just soldered the batteries together, since, I mean, there's no point in having a battery holder when you've got batteries that are going to last 10 or 15 years. So anyway, that was what I had, and what that does is, it's a keyer, and it's also a memory keyer, so you can add, like if you're calling CQ contest or CQ QRP or whatever, you can enter 30 characters into it. You can enter up to 30 characters into the memory, and set it to sit there and call. And you're just doing nothing but listening. You're listening for a response, and you can have two memories. And the other thing you can do is it has a beacon mode, and in the beacon mode it will send one of the memories over and over every 10 minutes or something like that. And so you can enter 30 characters in. Now, one thing that will be good for is if you had an emergency of some kind, you broke your leg out in some canyon or whatever, what you could do is throw up your little wire antenna and set the memory keyer to call Mayday and your call sign, I suppose. Well, I mean, I would certainly put my call sign in it, but you're probably going to get a response anyway, and since it's an emergency. But enough about that. So you enter Mayday, your call sign, and your coordinates where you are, and you set it to beacon every 10 minutes, and then you just listen. You go about your business, and if somebody hears you, they're going to respond. But even if you don't hear a response, somebody might hear you and relay the information, make the phone call to 911 or whatever. So you just keep it, transmitting every 10 minutes or whatever. And eventually somebody's going to hear it, especially if you park it on the QRP calling frequency. There are a lot of people that listen on that frequency and listen for weak signals on that frequency. So if they hear a Mayday on that frequency, they're going to do something about it. So that's enough about that. Continuing on. So I had, you see a couple of wires sticking out the back, and I put that in when I took the battery pack out of it. I just ran wires out so I could connect it to a battery like this or whatever. But as I mentioned, it doesn't need a battery like this. All it needs is a set of nickel metal hydride rechargeables or a pair of 18650 lithium rechargeables internally. And I had it set up, I've got a power jack in the back here, and that was a charging jack. And just had the on-off switch and charging jack, so I could charge it from a solar panel or a wall wart or whatever. And so headphones. In this case, it was some kind of test equipment, and it actually had a headphone jack, whatever it was. So since it said phones, I went ahead and just used, I put a 1/8 inch connector there for headphones, and this other connector is for the key if you wanted to connect an external key. But I mostly just used it, with the iambic or with the built-in straight key. And here's the antenna output and antenna port, and here's a ground lug that I added. And one last thing, little feature, I put a dummy load built in and a toggle switch to select the dummy load. Or actually, all it does is switches the dummy load in, but it doesn't disconnect the antenna jack. And the dummy load, I used a 100 ohm resistor, 5-watt resistor, and I don't remember, I think it was even a wire wound. So it's a very poor dummy load. It's basically just enough to keep you from burning up the finals. But the reason I did that is because a poor dummy load, a good dummy load is going to absorb all of the transmit energy. A poor dummy load is not. And that's going to give over 2 to 1. I mean, if it were a perfect non-inductive 100 ohm resistor, then it would be 2 to 1. But since it's an imperfect, lossy, inductive 100 ohm resistor, it's going to be over 2 to 1, probably closer to 3 to 1, but just enough to protect the final amplifier. And the reason I did that is because in the dummy load position, I can either use it as a dummy load with no antenna connected, and not much will get out. Some would get out, but not much. Or I can connect a wire of any length to that, and the longer the wire, the more energy is going to get out. But by doing that, I don't have to worry at all about SWR, because the dummy load is going to take care of any reflected power, or most of the reflected power anyway. So it'll keep it from taking out my finals. And what I used that for was, like, you know, if I went to 4 Days in May, which was the QRP symposium in Dayton, if I went to that, and I did, you know, I was a member of several QRP clubs, so I could go to that and be at the hotel room there, switch it to this position and put a 5-foot piece of wire on it, and sit there and talk to my buddies on 40 meters without, you know, people in Europe hearing me. And we actually did stuff like that. But you know, even with something that lossy, you still actually occasionally have somebody come back to you from hundreds of miles away, because radio's just like that, man. It's a lot of fun. So anyway, this is a great rig, and I had a lot of fun building it and modifying it and so on. And it was called the 4040 because the original version was 40 meters and cost about $40 to build. And originally you would buy a circuit board from Far Circuits, and then you would buy all the components and put it together. Well, then Dave, the inventor or developer of the 4040, started a company and quit his job and started a company building kits. And he called the kits, well, he called the company Small Wonder Labs, and he called the kit the SW40 Plus. And that's what this is. This is a Dave Benson kit. Just the board. And it was the circuit board and all the components. And then he made them in some other bands. And I've met Dave a few times, and I think all except for maybe the first one, the 30 meter one, I bought from him directly at Dayton. But on to the book here. This book, QRP Power, came out in the heyday of the 4040, 1996. And this is one of the best QRP books out there. Pretty sure it's out of print now, but there are a few of them still available. And if you look in the video description, I'll provide a link to this book on Amazon. I'd appreciate it if you buy one, or buy, you know, some of the other QRP books or something through my link, because that helps me out. Doesn't cost you any extra. But this book, QRP Power, and I remember when it came out, I bought it immediately. I was selling radio equipment at the time, and so I probably bought the first copy that came into Huntsville. But it says here, includes new article on NM1G's 4040 transceiver, and it does too. A great article. Really good description. And it includes revisiting the 4040. And it includes a couple of guys who really knew what they were doing, played with this radio, and did quite a few modifications to lower current draw and just various things. Improve the operating characteristics of it. And as you can see, there are a lot of pages of modifications they've done, improvements they've done. And even, you know, talks about battery packs and so on. Lots of good stuff. So, And here it is, the radio with the kit, with the antenna and everything. Of one of them, anyway. One of them set that up. Solar charging, lots of stuff about this little rig, and about actually using it in the field. And there are other good articles too. Modifications and improvements to the Hot Water 9. One of Heathkit's classic little QRP rigs. The Hot Water 9 was the last one of the series. It was the only one that was a super hat. This is a super hat, by the way. I mentioned that. Crystal filtered super hat with really good filtering too. But the Hot Water 9, I used to have one. I don't have it anymore. But I like the direct conversion Hot Water series better. The Hot Water 8 is the real classic. I've got a couple of those. But anyway, this book has a lot of good stuff about QRP operating in the field, build it yourself from QST, lots of good stuff. So I highly recommend this book if you're at all interested in QRP, and especially building your own QRP radios. You definitely need this book if you don't have it. And I was going to cover a couple of other little super hat portable rigs that were available back in the day, back in the 90s. And the other most popular of those, along with the 4040, was the NorCal 40A. I didn't build this one. A friend of mine who is no longer with us built this one. Not the friend I've been talking about lately, who recently passed away, but another friend who passed away about 10 years ago, I guess. And now that guy, he could design his own rig, and did, but he also, like me, enjoyed building kits. And this is a NorCal 40A. This was designed, I believe, by Wayne Burdick, the guy behind Elecraft, who designed the K2 and K1 and so on. I'm pretty sure that he, let's see, N6KR, I'm pretty sure that he designed this. I may be wrong, but I'm pretty sure that he did. NorCal 40A. Very popular little rig in its day. And like the 4040, a super hat and a good performing little radio. And I like it, but and a lot of people like this better because, you know, it was a complete kit with enclosure, controls and everything. Whereas the 4040, even if you bought it as the SW40 or SW30 or what, you know, it was per band. But even if you bought it as a complete SW kit, the complete kit only included the board and components. It did not include the controls, nor the enclosure or any of that kind of stuff. You had to come up with that stuff yourself. And of course it was less than half the price of a NorCal 40A too. And I just prefer to do it that way. I prefer to come up with my own enclosure and my own controls and everything, because I like to modify stuff, and I like to build more of it myself. In fact, I've built quite a few rigs from scratch, and my first home built rig I built from scratch. It was a direct conversion receiver. Okay, the last one we're going to look at is the SST. I think the SST was a NorCal Wilderness radio product too. Yeah, it was. The SST is a simplified version of the 40A. It too is a super hat, and you can see it's a small enclosure. I don't remember how much this was. It was more than the SW40 kit because it comes with its own enclosure and controls, but less than the 40A. But there it is. Like I said, also a crystal filtered superhet, and neat little radio. I bought the kit and built it just to be doing it. I mean, back then, man, anytime a new QRP kit came out, I almost had to build one. And but it's got board mounted controls. That makes it really simple to build. But you know, you get better results really if you come up with your own controls and enclosure and everything. But this does work well, and I got the 20 meter version because I didn't have any 20 meter QRP rigs at the time. So, and I was wanting to build an SST when they first came out. SST stands for Simple Superhet Transceiver. So this is SST 20, and I actually participated in a QRP contest with this one shortly after I put it together. Had a lot of fun with that. So that's enough for today. That's we covered some of the superhet simple QRP rigs, transceivers, and I've been into QRP for a long time, so we will be revisiting that with some more classic rigs and some simpler rigs and so on, plus what can be done with them. I would like to say in closing that this rig, it's like I mentioned, with a built-in battery pack that I had in it and just a piece of wire, you could operate for 100 hours, no problem. And with a solar panel like this, which I'll put a 5-watt solar panel in the link to that in the description as well, because every QRPer needs a little solar panel to bring along. With that solar panel, 5 watts, that's 20 watts per day approximately when you've got it out in the sun. So with that, man, you could stay out there and operate. You could operate for hours every day and have the solar panel replenishing your batteries during the day. And of course on 40 meters you're mostly going to be operating at night, or in the evening hours, because that's when it's most open. That's when it goes long. And if it were a 20 meter, if you were going to operate during the day, you could do some 40 meter operation, but 20 meters would be better. I've mostly operated 20 meters during the day, QRP. So that's it for today. Thanks for watching.